It may look like a rocket, but this is actually a car. And if British engineers get it right, the Bloodhound could be the world's fastest. It's designed to travel more than 1,000 miles an hour. That's Mach 1.4. Faster than a bullet, faster than the speed of sound. This full-scale prototype gets its initial kick of power from a Eurofighter Typhoon engine, but the real thrust comes at 350 miles an hour when a solid-fuel rocket fires up.
This is a 6-inch model of our 18-inch rocket. The real rocket in the car is about 4 meters long. We've got a Cosworth engine which spins up a pump, which pumps HTP, high-test peroxide, into the rocket at about 1,200 psi. Goes through a cat pack here which decomposes the HTP into high-temperature steam and oxygen-rich environment. Burns here at about 600 degrees C, ignites the rubber. The rubber burns. The rubber is basically aircraft rubber tyres with a little bit of extra magic in there, and then we get a large flame out the back.
The current land speed record of 763 miles an hour is held by the jet-propelled Thrust SSC. In order for Bloodhound to top that, it will need to be clocked twice in a 60-minute period.
Historically, it was a very simple thing to do. They'd get to the end of the run, turn the car around, kick the tyres, check they're okay, top it up with a bit of fuel and get back in and go back again. For us, our car is extremely complicated. It's got a lot of systems on board which need checking, and so we'll have to have a fairly tight time schedule to get that done within those 60 minutes.
Bloodhound's engineers have built a special simulator to demonstrate how the car will perform and stress it will endure.
It's very hard as the speeds go up. It's a lot harder for the steering, it's a lot more sensitive, and you can't stay on the line very easily. It takes a lot of skill, and I think children playing their PlayStations and games are a lot better at doing it than I am.
The Bloodhound will be let loose next year in a South African desert. If it reaches its target speed of 1,000 miles an hour, it'll cover a distance equivalent to more than 4 football fields every second. John Belmont, The Associated Press.